Hello and welcome to this video on integration by parts. We're going to use integration by parts in order to find the integral of e to the x cosine of x dx, and we will see we will get to use integration by parts twice. So let's recall the formula for integration by parts. We have the integral of u dv equals the integral of equals uv, and then minus the integral of v du. There we have that formula. So we choose u equals e to the x and dv equals, write the v sharper so that it looks different from u. And if dv is cosine of x dx, then we find that du is e to the x dx. The derivative of e to the x is just e to the x, and then we have the dx, while v is the integral of cosine of x dx, and that gives us a sine. Then by using u and dv the way we chose them, we get that the integral of e to the x cosine of x dx is u times b, and that's e to the x times sine of x, minus the integral of v du, and we have v is sine of x, while du is e to the x dx. We get e to the x sine of x minus the integral of e to the x times sine of x dx. And at this point, we realize that the integral of e to the x sine of x dx doesn't look harder or easier than the integral of e to the x cosine of x. So we say, okay, let's try to integrate by parts again. Let's choose u as e to the x, and this time dv is sine of x dx. Then du is e to the x dx as before, while v is the integral of sine of x dx, and that's negative cosine plus a constant we ignore. So we have e to the x sine of x, take away, and then we write the expression that is equivalent to the integral of e to the x sine of x dx. We have u times v. This time we get e to the x times negative cosine of x, and then minus the integral of v du, and we have minus cosine of x times e to the x dx. So we have that the original integral is e to the x times sine of x, then the negative changes the sign of everybody inside the brackets. We have minus e to the x times minus cosine, so plus e to the x times cosine of x. Then minus minus gives us a plus, and then we have a negative. So negative, let's write the exponential first. We have this. And we realize that the integral we're trying to find, which is the integral of e to the x cosine of x dx, is the same as something minus the integral. So we have e to the x sine of x plus e to the x cosine of x minus the integral. As we solve for the integral, we find that y is the integral I plus I, as we bring this negative I to the left, or same thing, we add I to both sides of the equation. We get twice I equals e to the x sine of x plus e to the x cosine of x. Then the integral we're trying to find is a half of e to the x times sine of x plus e to the x times cosine of x, and we add the constant. We usually have the integration constant, and that's the answer to the problem. So in this example, we see that it's necessary to use by parts more than once in order to find an integral. Okay. If you have any questions, make a comment and I will try to reply as soon as possible. Thank you for watching. Bye bye.